Let's solve this initial value problem by applying Laplace transform. So here we have the differential equation y double prime minus y prime minus 12y equals 3, and the boundary conditions are y of 0 equals 0 and y prime of 0 equals 0. So first let's apply Laplace transform. So let me copy this equation y double prime minus y prime minus 12y equals 3. So let's apply Laplace transform to both sides of this differential equation, and this will be Laplace transform of 3. Now we apply linearity to the both sides, particularly to the left side, and when we do that we get Laplace transform of y double prime minus Laplace transform of y prime minus Laplace transform of 12y. This is 12y, and this equals Laplace transform of 3. I'm going to write down this factor 3, and we have a Laplace transform of 1. Now we can use the Laplace transform formula, that is Laplace transform of y prime and Laplace transform of y double prime. So let's replace those formula here. Laplace transform of y double prime is s squared Laplace transform of y minus s times y of 0 minus y prime of 0. So let me close this. Minus we then have the next term Laplace transform of y prime, which is s times of Laplace transform of y minus y of 0. So now let's write the Laplace transform of negative 12y. I can factor the negative 12, that is the 12, and then the Laplace transform of y. And so this equals, on this side we have 3 times of Laplace transform of 1. Now let's put the boundary condition, that is y of 0 equals 0 as plus y prime of 0 equals 0. And so therefore this term will become 0. This y prime of term will also become 0, and y of 0 term will also become cancelled. So now let's simplify this. So on the left side we have s squared Laplace transform of y minus s times of Laplace transform of y minus 12 times of Laplace transform of y, and this equals 3 times of, we can now write down the Laplace transform of 1, which is according to the Laplace transform formula, it is 1 over s. And so we can write down this 3 times of 1 over s as 3 by s. On the left side, we can factor out the Laplace transform of y. And so when we do that, we get Laplace transform of y times of s squared minus s minus 12. And this equals 3 by s. Therefore, we now divide both sides by this expression, so that on the left side we will be left only with the Laplace transform of y, and this equals 3 divided by s times s squared minus s minus 12. Now the Laplace transform of y, this is equal to y of s. It's going to be a function of s, and this equals, on the right side we have 3 divided by s times of s squared minus s minus 12. And this completes part A, wherein we have written the equation for y of s. In part B, we write down the right side expression using partial fraction decomposition from equation y of s. So first let's write y of s. This equals 3 divided by s times of s squared minus s minus 12. And we see that this is a quadratic expression which can be written in factor form, that is s squared minus s minus 12, and this equals We can factor this as a product of two linear factors, that is s minus 4 times s plus 3, because the product is negative 12 and when the sum is minus 3. So here we have this product negative 12 and the sum equals negative 3. And so this factorization is perfect. So therefore this y of x, I'm sorry, it is y of s. This is written as 3 divided by s times of s minus 4 times s plus 3. Now we are going to write down this right side expression by writing using the partial fraction decomposition. So therefore we write 3 divided by s times of s minus 4 times s plus 3, and this equals, we can write this as a sum of three partial fractions, that is a by s plus b by s minus 4 plus c by s plus 3. Now we should find the values of a, b and c. First we multiply both sides by the least common denominator, which is this product, that is s times of s minus 4 times s plus 3 is the least common denominator for both sides. And when we multiply this both sides of this expression with this LCD, on the left side we'll be left with the 3, and on the right side we will have the first term, that is a, divided by the term which it doesn't have when compared with the least common denominator. For a, the denominator is s, and so if you look at this least common denominator, we don't have s minus 4 times s plus 3. So we have to multiply a with s minus 4 times s plus 3. And for b, the denominator is s minus 4. So when you compare this s minus 4 with the LCD, the terms it doesn't have is s times s minus 3. So therefore b has to be multiplied with s times s plus 3. And similarly c has to be multiplied with the term which it doesn't have in the denominator when compared with the least common denominator, that is c has to be multiplied with s times s minus 4. Now let's determine the values of A, B, and C by plugging in some random values for S. So first I'm going to put S equals 4, and so when I do that I get 3 equals. When you plug in S equal to 4, this term will become 0, as plus this term will become 0, and we'll be left only with this term. So let me plug in S equal to 4. So it is B times of 4 times here if we plug in 4, it will be 4 plus 3, which equals 7. And so this equals 3 equals 4 times 7 is 28. It's 28b. And so this gives b equals 3 over 28. Now we put s equals negative 3. And when we do that, this term will become 0. Also, this term will become 0. And so on the left side, we have 3 equals. Here we will put s equal to negative 3. So it becomes c times of negative 3 times, if we put negative 3 here, we get negative 3, negative 4 is negative 7. So this gives 3 equals negative 3 times negative 7 is positive 21. So it is 21c. And so solving for c, we get c equals 3 by 21, or it's equal to 1 by 7. So we found the value of c equals 1 by 7. Now let's put s equal to 0 into this equation. Yes, we put s equal to 0. And when we do that, this term will become 0. Also, this term will also become 0. So on the left side, we will have 3. And this equals a times of, we put s equal to 0 here. So it is negative 4. We also put s equal to 0 here. It will be 0 plus 3 equals 3. And so this gives, we can divide both sides by 3. So we get 1 here. So 1 equals negative 4a. And so solving for a, we get a equals negative 1/4. Thus, we have determined the values of a, b, and c, which means we can go back and substitute into this partial fractions equation. So therefore, we write 3 divided by s times of s minus 4 times s plus 3. And so this equals a is negative 1/4 divided by s plus, let's replace b, which is 3 by 28. This is divided by s minus 4 plus c is 1 by 7. This is 1 by 7 divided by s plus 3. And so this can be simplified further. That is, this is equal to negative 1/4 times 1 by s. And this is written as 3 by 28 times 1 over s minus 4. We then have 1 by 7 times 1 over s plus 3. Thus, we have written y of s, which represents this fraction in terms of partial fractions. So we can write down this as y of s, wherein this represents b equals 4, and this represents c, this equals negative 3. This completes part b. Now we can solve this equation by applying the inverse Laplace transform. So therefore, we write Laplace inverse of y of s, and this equals Laplace inverse of negative 1/4 times 1 by s. We apply the Laplace inverse to all the terms on the right side, and this equals, I can factor out the constant 3 by 28, and then write Laplace inverse of 1 over s minus 4 plus factor the 1 by 7 times Laplace inverse of 1 over s plus 3. And so this gives the Laplace inverse of y of s, which is written as y of t, and this equals factoring the negative 1/4 from the first term. We then left with the Laplace inverse of 1 over s, which equals 1 plus 3 by 28, and the Laplace inverse of 1 over s minus 4. This equals e power 4t plus we then have 1 by 7. The Laplace inverse of 1 by s plus 3. This equals e power negative 3t. That is, we do this using the formula, that is Laplace inverse of 1 over s minus a equals e power at. So this is the formula that we use to find the Laplace inverse of the two terms, so that we get e power 4t and e power negative 3t. And thus we have find the solution of the initial value problem, that is y of t equals negative 1/4 plus 3 by 28 e power 4t plus 1 by 7 e power negative 3t. This can be written as just negative 1/4.